Okay, so in the previous session, we have seen how we can add pivotal cardinal direction stuffs. So if I play it real quick in the preview mode, so this is what we have currently. So we have start animes, cycle animes, stop animes, plus pivotal animes for the cardinal direction based movements. Plus we have idle and idle breaks for the idle states. Right. So I think we have sort of a defined overview for our locomotion system, but I think maybe we can improve this data structure further because currently it support this jog states, but later on I'm thinking about adding sort of like walk animations and crouch animations, things like that. So in order to leverage those features, I think it's better to improve this data structure further. Right, so let's see how we can do that. First I think we have to go for the structs, locomotion and imset. So this is the core data structure that we are going to use when you are populating this dt and imset. You can see it here. So currently it has idle breaks and jog. So additionally, maybe we can add one more record for walk and another record for crouch. But let's say if we reuse this data structure, which means it has already the cycle, start, stop and pivotal cardinals. So maybe we can reuse this data structure to define our walk and crouch states. But first, I'll rename this as anim movement, which gives a much more generic meaning for that specific data structure. Save all. So if I go to the structure now it's in anim movement type, right? So now what we can do is we can create set of two records called walk and crouch and add this to this specific data structure, right? So let's see how we can do that. But I think maybe maybe we can generalize the data structure further as well, because ideally this idle and idle breaks also come along with this S movement data structure, I believe, because all of those comply under one category which is relevant for movements, right? So I think maybe we can move these two for the any movement data structure itself, right? So we have one record for this idle, which is anim sequence. So let's add that to here. So it's type of anim sequence, and we have another variable called idle breaks, which is anim sequence array. I'll make its type as array. Okay, now maybe we can do some sort of a rearrangement, because I think it's better to have an idle break in the top position, and then maybe we can swap these start cardinals with cycle cardinals as well. So it has a much more descriptive meaning, right? Because we start with the start cardinal, then it goes to cycle cardinals, then at the end it goes to the stop cardinals. Right? These are the 3 plus configurations at the end. If I save all, and go to here, now we have those 2 records or fields at the data table itself. But before removing these 2, first let's reassign their values by simply copying and paste. So we won't lost those values once we remove these 2 variables. Okay, we have those 2 here. Then what we can do is we can go to this anim set itself and try to remove these 2. Okay, so if I go to the data table now there is no prior record called idle and idle breaks at here, right? Okay, now if I go to the ABP locomotion and try to compile it, definitely it gives an error because now it can't find out these pins at the data structure level itself. So what we can do is give me a second, let me check out my documentation. Yep. So what we can do is maybe we can break this further and refresh the nodes, and we can plug these idle and idle breaks to here, right? Okay, now that error has been gone, and if I play a test is now, yeah, so idle and let's say idle break, yeah, idle and idle breaks works properly, and other movement cardinals are working. Okay, so that's the first change we have to do. And so since I'm going to have some sort of generic data at here, maybe we can maybe we can assign these to a set of group called maybe movement group, right? So let's create a new blueprint data structure called SNM movement group. And in this movement group, I will have 3 type of movement groups. The first one is walk, which is the type of anim movement. The second one is basically jog, and followed by we have crouch. CRO usage. So these are the 3 movement groups that we can introduce for this game. Now inside this SNM set, let's add that movement group called, let's say, movement, right? And it should be the type of movement group. If I save it and go to the SNM set the table, now you can see we have a record called S movement. Inside that we have 3 fields, each dedicated for specific movement type, right? So we have walk and jog and crouch. So I'm going to remove this variable, but first, like we did before, let's copy these values and I'll paste it to here, right? So we don't need to reinitialize those stuff once we remove those variables, right? Let's save it all. Let's go to this anim set and let's remove this field. If I go to the data table again, now it doesn't have that record. Instead we have these three records or fields here. Okay, again let's go to the ABP Locomotion, and yes, if I compile it, everything will break because there is no jog related feature here, right? So now we have to determine what is our movement type, plus based on that movement type we have to filter out whatever the movement structure we want at here. So now to do that, I think maybe we can create an enumeration to distinguish those stuff. So let me quickly see my documentation for a bit. Yep. So let's create a new enum called blueprint enum e movement type. So for now I need three type of movement types. So maybe initially it is just none, right? Which means maybe a T pose. Then we have walk movement type, then jog, and finally crouch. So those are the possible movement types that I can think of. But if you need to add more movement types, you can simply populate this data structure. Actually, it's not a data structure, it's an enumeration, right? Now let's assign that enumeration for our locomotion component itself. So this is the BPC locomotion system component, and I'll add a variable called movement type, which is the type of that enumeration. Movement type. I'll make it as public variable and assign it to the setup category, and maybe I can move it. Yeah, maybe move it to here. Right? If I save now and compile, it gives the error because now it has this issue. Right, so let's see how we can fix that. Okay, so first thing, here we are getting our movement data structure, but since we remove this field, now it can't point for a specific movement data structure, right? So what we can simply do is we can create a helper function called get movement from movement type, and here I'm passing set of possible movements, which is movement group, and a possible movement type, which is the type of movement type enumeration. And as the output, I'll simply return movement, right? So here we are passing movement group, and based on the movement type enumeration, it do a filtering and return a specific movement structure for us. Now I can break this thing. I can add a select here, and as the index I can point this movement type, right? So for work state I can point this one, for the jog this one, and crouch this one. Okay, and save, and maybe we can make it as a pure function, right? And let's go to this movement config from anim set here, and we can assign it to getters category, and let's call this thing. So now we can pass this movements data structure, and as the movement type you can assign it to here, and yeah, so basically this one is getting the configurations, right? So maybe we can break this thing, and here we have configurations, so we can pass it like this. I'll hide the unconnected pins, right? So now if I compile it, now that error has been gone, because now we are rendering based on the movement type instead of referring it as directly. So as the default movement type, maybe we can make it as jog, right? But if you want, you can make whatever you want, but I think ideally it would be fine to make it as jog, right? And then let's go to the app locomotion itself, and here also we need to do some type checking before directly getting this movement structure, right? So let's go to the not thread save function, set animation data. Right, so this is the type of what? This is the type of anim set type. So let's break this thing. Yeah, now we have movements, and I think yeah, I think we can reuse the logic that we have at here. Right, so maybe I'll copy the function right for now, right, and paste it here and assign it to the maybe helper functions, and let's go to set animation data and plug that function here, right? And then as the L movement struct, currently it's pointing a specific anim set, is not quite ideal. Instead of that, it should be a anim movement, right? So I'll change its variable type and compile, and it introduced a set of new failures, but that's fine, we can resolve those stuff later. And I'll unpin this link and add this link here, right? Okay, now that error has been gone. Plus we need to add a new variable for this enumeration type as well. So I'll add a I'll add a new variable for that called ls movement type, and we have this locomotion system. Yeah, it should be ls underscore movement type. and I'll move it to here. Okay, and then what we can do, yes, and mm, then let's resolve these issues first. So we have an issue at here. Yes, so now I think we don't need to break this thing. Instead of that, we can directly plug it to here and compile. Yeah, error has been gone. Let's go to this error again. You don't need to break it. We can plug it to here, and those errors has been gone. So if I quickly show you where those errors present at this collapsed node group set idle and idle breaks, we had the reference to resolve, which is this one, and at these cardinals collapsed node category, we had another reference to be resolved, which is this one. And maybe I can give a proper name for this one. Cardinals including start, cycle, stop, and pivot. Right. Maybe this one I can rename this as idle breaks. Right. Okay. And then we have to set this movement type dynamically, right? Because currently it is setting as what do you call statically type, because I just promoted it to a global variable, but ultimately this should be taken from a specific event dispatch or any sort of a interface like that. So I think we had those interfaces at the initialization, right? There we may need to add a new event dispatcher listener like this. But first, before adding that binding, we should have a event dispatcher has been defined at the locomotion system itself. So let's go to the component level. I'll create a new event dispatcher called event on set movement type. Compile and save. And here I simply passing movement type as the input. So it should be in the type of movement type enumeration. Compile, save, and then let's go to the ABP locomotion layer itself, and maybe at the very beginning we can do that binding, but it doesn't matter the order of binding, right? Because at the initialization all of will be binded, so therefore I'll add a binding here. So let's call bind event to event on set movement type. I'll plug it to here. And let's create an event with the matching event, and I'll rename this as event on set movement type. And let's move that to this locomotion event graph section and compile. So it breaks the reference because we have been moved this event pin to here. So let's go to the create event again and reattach it and compile. Now that error has been gone. Then we can go to this event on set movement type, and we can set this thing out. But before setting it, first we can check whether the movement type is different or not, right? So if the movement type is different, then we can reset the movement type. Otherwise it would be the same thing, so no need to reinitialize it again. Okay, so if this is changed, then yes, I'm resetting the variable, right? And then I think we have did the what we have did on the event on anim set. Whenever we make a reconfiguration, we reset the animation data itself as well. So we have that real-time updates for each change, right? Right. So let's copy this function call and paste it here. So whenever we change the movement type, we reset in the, or we update in the animation data as well. Okay, now that function has been called as well. So then what we have to do is basically we have to trigger this event dispatcher properly on this PPC locomotion system, right? So let's see how we can do that. So maybe at this event tick, we can add this thing, or else yeah, or else at the begin play we can set the moment type as well. But first let me quickly look at my documentation. Yeah, so like we did here, yeah, like we did there, maybe we can create a new function. Let's say set movement type, right? And as the input, I'm getting the movement type, like we did here or here. So I'm checking whether they are not, whether they are different or not. So if they are different, that we have been provided here, then we do a switch, or then we do a transition or resetting of this variable. So can plug it to here, right? And once that change has been done, we are sending a signal via this event dispatcher so that the ABP locomotion script, which is the listened component, will receive that message and do a state transition, right? And as the movement type, we can plug this movement type variable. Okay, and then at the begin play, like we did here, what we can do is we can call the set movement type function with the provided global movement type variable, right? And I'll assign it to the setters category. Okay, right. Now if I play this, it only show in the TPS. So let's first check whether we are receiving the movement type properly. If I add a print statement here, it is ls movement type. Play it again. Yeah, I think yeah, it is not receiving properly. Yep. So let's remove these pins and let's add a print to here. Yeah, that thing is not being called. Why is that? So if I go to this function, yes, I think I know why it's not been called, because we are doing a type check at here. So I think ideally we don't need this here because we have that checking at the ABP locomotion level as well. So let's remove that thing, compile, save, and play it again. Yeah, now we have the proper transition. Because what happened is that initially the movement type is jog, and if we check it at the begin play, it is in the exact same type, which has not been changed. Therefore this event dispatcher is not getting called, right? That was the issue that we had before. But if I remove that condition or type checking, then that issue has been gone, right? Because at the very first frame onwards, it just calling this event dispatcher, and it goes to this ABP locomotion level and listen to that event at here. And once that event has been received, it call this event on set movement type event, and there it does a type checking, right? Because if you look at the ls movement type here, it is simply none, but we are passing a jog as the initial type, so it is a different type. Therefore it execute this set animation data, right? So that's the logic that we have been implemented right now. Okay, so I think currently it's only do this transition for the jog, because if I go to the, let's say, characters, blueprints, and play, and if I switch the movement type to maybe walk, it will not show any animations, right? Because we haven't set any walk animations yet, right? Or even for crouch, it won't make any significant difference, right? It's just a TPS, right? Because ideally we should populate these values at this data table instance, right? Okay, so maybe in the next tutorial, let's see how we can do those configurations for other movement types, and see you there. Thank you.